Welcome to the first of two videos on the applications of right triangle trigonometry. The goal of this video is to solve right triangles. Many real-life applications do involve right triangles. The real-life application problems will be in the next video. This video will review how to solve a right triangle. To solve a right triangle means you determine the measure of all three angles and determine the length of each side. Two basic ideas we should already be familiar with are the Pythagorean theorem, and also that the angles of a triangle have a sum of 180 degrees. So let's solve this right triangle. So the first thing we have to recognize is we have a right triangle, so this measures 90. This measures 36.87 degrees. We know that the two acute angles of any right triangle are complementary. So to find angle B, we can just take 90 degrees and subtract 36.87 degrees. And we can see that would give us 53.13 degrees for angle B. Next, we're missing this side of the right triangle, and we can use the Pythagorean theorem to figure out the missing side here. Remember that c squared is equal to a squared plus b squared, so we would have 15 squared equals 9 squared plus x squared. Let's isolate x squared. If we subtract 81 on both sides, we'd have 144 equals x squared. Square root both sides of the equation. X equals 12. So AC is equal to 12 units. And we have all the angles and all the sides, so we've solved the right triangle. Let's go ahead and try another. We have a right triangle, so these two angles are complementary. So 90 minus 62 would give us angle A. That would be 28 degrees. Notice on this triangle we only have the length of one side, so we can use trigonometry to determine one of the two other sides. Let's go ahead and try to find the hypotenuse first. What we'll do is we'll use this angle that we know is 28 degrees, and we can figure out how we can relate this angle to this leg and this hypotenuse. And if we say that the cosine theta, or cosine 28 degrees, would equal the adjacent side over the hypotenuse. So 7 over c. And now notice we only have one unknown. So now we can use the calculator to find the value of cosine 28 degrees. Make sure your calculator is in degree mode. And we'll use 4 decimal places, so 0.8829 is equal to 7 divided by c. So if we multiply both sides by c, we'd have 0.8829c equals 7, so we need to divide. This implies that c is approximately 7.9 units. Now we still need to find the length of side A, and to do this I'm going to use this angle again, but I'm going to use tangent this time. I'll say the tangent of 28 degrees equals the opposite over the adjacent side. So we would have tangent 28 degrees equals A over 7. Now one reason I didn't want to use C is because I knew this was a rounded value. So if I use a rounded value, it will cause more of an error when we find the length of A. So the tangent of 28 degrees is approximately 0.5317. Here, if we multiply both sides by 7, we will have the value of A. Looks like it's approximately 3.7 units. Now we have a solved triangle. We have the measure of all the angles and the length of all the sides. So we're done. Let's try one more. Notice on this problem we're missing the two acute angles, so we're going to have to use one of the inverse trig functions to find the measure of angle A or angle B. So let's go ahead and use angle A. Using sine, we'd have the sine of A is equal to 5 over 13, or the opposite over the hypotenuse. Now if we take the arc sine or inverse sine of both sides, And on the left side, the inverse sine of sine A just gives us angle A. And on the right, we can go to our calculator and determine this angle. Remember, inverse sine is second sine, 5 divided by 13. And the angle is approximately 22.6 degrees. So if angle A is 22.6 degrees, or approximately, we know these two are complementary. So 90 minus 22.6 would give us 67.4 degrees for angle B. This video leads up to the real-life applications that involve solving right triangles, so I recommend you watch that video next. Thank you for watching and have a good day.